Hi folks, well here I am all dressed up and nowhere to go. I'm still waiting for the skies to clear so I can get my first imaging session of this season off with a session on the Veil Nebula complex, but things aren't playing ball at the moment. Hopefully it won't be too long before they are. So what I've been doing since waiting for the skies to clear is thinking about how long light takes to get to or get from a particular object to a telescope. Now we know that's fairly easy to work out. Something's 1,000 light years away, it takes 1,000 years, right? That's fair enough. But what I was more interested in is thinking about, well, what was going on in Earth at the time it left its origin to get here. And so in other words, to try and put this time period in context. So what I did was performed that exercise for a number of deep space objects that are commonly imaged by astrophotographers. And it's actually, I found it quite an interesting exercise. So let's go and have a look. I'm Dr. Ray and welcome to AstroGadge. So just in case you're wondering what this thing was, it's basically a couple of weights I cobbled together to fine-tune the balance of the 61 EDPH2 on the EQ8 because it was a little bit heavy in the RA axis. So just added a couple of modified diver's weights and attached it to the telescope, and it's now spot on. So like I say, all I need now is some clear skies. Anyway, back to the video. So let's look at some objects that are commonly imaged by amateur astrophotographers, and let's do it in the order of distance from the Earth. So let's begin with Galaxy M87, which is in the Virgo cluster. It's pretty distant, at 53.5 million light years away. So that means that the light has taken 53.5 million years to reach your telescopes. So that means that light left this particular object during a period in the Earth's history that's referred to as the Eocene epoch. And that's when the first true mammals start to appear and diversify on the Earth. And it's a time sort of following the extinction of the dinosaurs. So by anybody's standards, that's an awful long time ago. You'll notice that I'm going to be using the phrase around about the time of, and that's simply because of the uncertainty of measurements, both in terms of celestial objects and indeed time periods on Earth. The next object that we're going to consider is Bode's galaxy, or Messier 81. Now light left that particular galaxy around about 12 million years ago. It's 12 million light years distance. And that corresponds to a period in Earth called the Miocene epoch. And during that particular time on Earth, mammals and birds were pretty well established and actually fairly recognizable as modern sort of creatures. However, Recent studies, such as one that appeared in Nature recently, suggest that around this time, early hominids, or the first hominids, that is the earliest precursors of humans, started to evolve. There's been some recent fossil evidence to suggest this. Before this, it was thought that the hominids, or pre-humans, evolved about 6 million years later. So it's quite a thought, really, to think that the light hitting your telescope when you're looking at this object actually left that galaxy long before modern man existed. Moving on now to the Andromeda Galaxy, or Messier 31 as it's known. It's a popular astrophotography target. It's visible to the naked eye in the constellation of Andromeda, and light left there 2.5 million years ago. So what was happening on the Earth then? Well, it's around that time that evolution of true humans occurred, in particular Homo erectus, and it's known that Homo erectus was able to use fire, and other fossil evidence suggests that they were also successful hunters. So again, something to think about when you next time you look at Messier 31 is that the light reaching your eyes left there just around about the time that humans had appeared on Earth. Okay, getting a bit closer now, and let's consider the bubble nebula in Cassiopeia. Light left that particular object 10,000 or around 10,000 years ago. That corresponds to Neolithic times on Earth. At that time, Homo sapiens, pretty much modern humans, were well established, and it's a particularly important time in history on Earth because it's when humans made the transition from being hunter-gatherers to a more agricultural society, where it was able to sort of form early civilizations. In many ways, the Neolithic humans were really only a cultural and technological step behind what we are today. Moving still closer now, we've actually got again another very popular target, the Veil Nebula. Light takes 2.4 thousand years to reach the Earth from the Veil Nebula, and that period of time is around the time of the Roman Empire. As I understand it, sort of getting towards the sort of end of the Roman Empire. At that time, Rome had pretty much subjugated most of Europe. They had advanced armies and navies, and were able to introduce sort of new technologies to fairly primitive societies in Europe at that time. Again, something to think about when you're imaging this object, that the light's Roman. Of course, we're only talking about Europe. I'm not too sure about anything other than European history at that time. Finally, another very popular target, the Great Nebula in Orion, otherwise known as Messier 42. It's readily visible with the naked eye, and light left there around 1.3 thousand years ago. So that means that the light hitting your camera or your eye left that object around the medieval times, or Dark Ages as they were referred to in Europe. This was a pretty miserable time to be alive in the Middle Ages, where disease, superstition, violence and torture were sort of commonplace, as was brutal punishment for any crime you were convicted of. It was very much a feudal society, and life expectancy wasn't too long, to say the least. It's also around the time of the Spanish Inquisition.
Nobody expects the Spanish Inquisition!
Where failure to abide by the Catholic doctrine or acknowledge the Catholic Church resulted in a very painful and long drawn out death. So I hope you find that interesting. I certainly found it an interesting exercise. This whole looking back in time thing always kind of blows my mind a bit. That's all for today. Hopefully, like I say, the sky's going to clear up. We'll get some imaging done in the very near future. Meantime, thanks for watching. Feel free to hit the subscribe button, which is down there somewhere. And we'll see you soon. Again, thanks for watching. And remember, keep watching the skies.
Watch the skies everywhere. Keep looking. Keep watching the skies.